Hello, my name is Jeremy Arit Rajaratnam, and today me and my team are going to present on the disease in the oil palm plantation. So before we go into the disease, we will first talk about what is oil palm. So oil palm is encompass both the Elais guineacis, native to Africa, and Elais oleifera, native to South and Central America. So this plant species is typically used in the oil industry, where we harvest their fruit in order to get the oil and process it into cooking oil. The oil from the fruit is extracted from both the pulp and kernel of the fruit. In Malaysia, we highly depend on oil palm plantation in order to boost up our country's economy. So therefore, if the plantation of oil palm in Malaysia is affected with any type of disease, it would lead to the loss of the country's economy, because oil palm is one of the major contributor of the country's economy state. Next, we'll be moving on to the first disease that we'll talk about, which is called the basal stem rot. So the basal stem rot is caused by a fungal which is called the Ganoderma boninense. So how do we identify whether or not our oil palm plantation site is being affected by this disease? There are many signs and symptoms that can be shown by the fungal, which can be identified, one of which is the collapse of lower fronds. So as the disease advances, the affected fronds may collapse and die. This can result in the progressive loss of foliage in the lower part of the palm. The second symptom that we can look is the formation of chunk or sporophore. So the chunk or sporophore formation is a distinctive sign of basal stem rot, where this chunk will grow or will be formatted at the base of the trunk of the oil palm tree. So the shelf-like structure is the reproductive organ of the Ganoderma fungi and is often visible externally. The next symptom that we can look into is the internal tissue decay. So basal stem rot primarily affects the internal tissue of the oil palm, leading to decay of vascular tissue in the trunk. The decay weakens the structural integrity of the palm. The next symptom that we can look into is the gradual decline and death of the oil palm. As the disease progresses, the overall health of the oil palm declines. The palm becomes more susceptible to wind breakage, and the eventual result is the death of the infected tree. So in order to control this disease from it getting more worse and spreading into the plantation site, there are few management that we can apply in the plantation. One of which is the cultural control. We can reduce the growth of the disease by improving our drainage system, and as well improving the growth condition of crop, because we do not want to create an environment state where the pathogen can infect the plant easily, as well as letting the pathogen reproduce in an environmental state which it prefers. The next management that can be applied is soil mounding. Soil mounding provides additional support to the crop and stimulates root production. It is also an economic technique. So soil mounding is where we put soil at the base of the trunk, where it's similar to mulching, where it will maintain the moisture of the base of the plant. It doesn't create opportunity for the disease to grow at the base of the plant. Another management that we can look into is the chemical control. Chemical control by injecting fungicide such as hexaconazole into the plant. This will kill any pathogen from infecting the plant, therefore protecting the plant. But chemical control is not always the right management, because it might lead into environmental issues, as well as the lowering of the oil palm quality. So how does the basal stem rot affect the economic of oil palm? So one of the economic loss that we can see is the reduction of oil yield. Basal stem rot leads to a decline in oil palm productivity, as the disease compromises the structural integrity and vitality of the palm. The affected palms may produce fewer and lower quality oil-bearing fruits. Other than that, it can also increase the production costs. Controlling the spread of basal stem rot requires additional resource and increased production costs. This includes the cost of implementing disease management measures such as removal and disposal of the infected palms, replanting, as well as adopting preventative strategies into the plantation site. Loss of land productivity also contributes to the economic loss of oil palm because basal stem rot not only affect individual palms but can lead to the loss of entire planting areas. Infected areas may become unproductive, reducing the overall land productivity of the plantation. So the next disease that we look into is called the upper stem rot, which is also caused by Ganoderma bonines. So what are the characteristics of Ganoderma bonines? There are a few. The pathogen is characterized by its typical bracket-shaped fruiting bodies, also known as chongs. The chongs are woody and can be annual or pre-annual structures. This pathogen primarily is a soil-borne pathogen that infects oil palm's root. So how do we identify whether the plantation site is being infected by the upper stem rot? So one of the symptoms that we can look at is the internal rotting. So the fungus Ganoderma bonines primarily attacks the internal tissues of the oil palm stems. The rotting process occurs within the stem, leading to a loss of structural integrity of the tree. The next symptom is that we can see the formation of the mycelial fans and chongs. In the advanced stage, the pathogen may produce the mycelial fans or chong, also known as the fruiting bodies, on the external surface of the stem. These structures are often observed as a white to light brown fungal growth, indicating the presence of the Ganoderma fungus. The next symptom that we can look into is the crown reduction. As the disease advances, the oil palm experience crown reduction, where the number of healthy fronds decrease. This is a consequence of the progressive decay and death of the internal tissues, impacting the overall health and vitality of the plant. So next we'll look into the ways that we can manage the disease. So one of the ways is by practicing the sanitation practices. We can implement good sanitation practices to minimize the spread of the fungus. Remove and properly dispose of infected palm residues, including prune fronds and affected tissues, to reduce the in-column source. Next, workers in the field can focus on the field monitoring part, where regularly monitor oil palm plantations for symptoms of the upper stem rot. Early detection allows the timely intervention and helps prevent the further spread of the disease. Next is mulching. Apply organic mulch around the base of the oil palm trees. Mulching helps regulate soil temperature, conserve moisture, and may contribute to overall palm health. Next, we'll look into the economic loss due to the disease infecting the plant. One of the economic loss is the replanting cost. The removal of infected plants and the subsequent replanting of affected areas with disease-resistant varieties involve a huge cost. This includes expenses related to acquiring new planting materials, land preparation, as well as labor. The next economic loss is the environmental impacts. Economic losses due to upper stem rot may also be associated with environmental consequences. The removal and disposal of infected palms can lead to changes in land use, affecting the biodiversity and ecosystem service. The disease can also affect the global supply chain impact. Economic losses from upper stem rot can affect the global palm oil supply chain. Reduced yield contribute to fluctuation in oil palm prices, potentially impacting profitability through the supply chain. That's all from me. I'll pass to the next presenter.
Hello, my name is Terence. Today we'll present the three main diseases on the oil palm, which is sudden witter, vascular wilt, and dry basal rot. The first one is sudden witter. The causal agent or the pathogen for the sudden witter is a genus Ganoderma. The signs and symptoms for this disease is a result that impair water and nutrient uptake. The oil palm trees infected with the Ganoderma fungi exhibit the symptoms such as wilting of the leaf, reduced fruit production, and the characteristics wilt appearance, where the frond or the leaf suddenly drop and wither. The management for this disease, which is select two management. The first one is site selection and preparation. First, choose the well drain and elevate the planting site to reduce the risk of the waterlogging, and avoid the planting the oil palm trees in an area with history of Ganoderma infestation. The second one is sanitation practices, which is to implement strict sanitation measure to remove and destroy the infected palm trees. Properly dispose of the infected palm materials such as the roots and the fronds by burning and burying them deeply. The effect of the disease to the yield or the economy of the oil palm. It severely impair the oil palm ability to produce fruit. This result in significant reduction in oil palm yield, leading to economic loss for the oil palm plantation or the grower. This happened because of the fungus disrupt the flow of the water and the nutrients within the plant, leading to the loss of turgidity and vitality in the upper part of the tree. Okay, the second one is a vascular wilt, which is the causal agent for this disease is a Fusarium, verticillium, and ceratosis. The sign of the symptom in this disease is the plant affected by the vascular wilt typically show the symptoms such as wilting of the leaf, yellowing, or the browning of the foliage, stunted growth, and in some case the plant death. These symptoms often start on the side or the branch of the plant and gradually progress. The management for this disease is crop rotation, sanitation, biological control, and chemical control. The crop rotation, which is the plant non-host crops in affected area to reduce the buildup of the pathogen population in the soil. The sanitation, we do the proper disposal of the infected plant material and the soil to reduce the source of inoculum. The biological control, the use of the beneficial microorganism that can suppress the growth of the vesicular wilt. And the chemical control is do we use the fungicide or the bactericides may be considered, but this is the typically less effective or the not always practical. The effect to the economic and the yield of the oil palm, which is the stunted growth, reduce the fruit production, which is the oil palm fruits production is heavily depend on the health and the vigor of the palm tree. The vascular wilt disease can be lead to a significant reduction of the fruit yield. And the third one is a premature of the death of tree, which is in such case the oil palm tree infected with the vascular wilt pathogen may be died prematurely. And the third one is a dry basal rot. The causal agent for this dry basal rot disease, which is a serpula. The sign and the symptom of the dry basal rot is often start at or near the base of the tree, where the fungus enter through the wounds or a decaying roots. Common signs of the dry root included brown, brittle, and a crumbly wood, which is often has a cubicle and cracking pattern. The management for this disease, which is the first management, I will choose the preventing, which is a pruning maintenance, water management, and the sanitation. Second management, which is we do a treatment management, which is a fungicide application, stabilization. The pruning and maintenance, which is regularly inspect the prunes of the tree and remove the dead or the weakened branches to reduce the risk of the injury or the entry point for the fungus. The water management, just we avoid the overwatering trees to ensure the proper drainage around their base. The sanitation, we do the dispose of the infected wood properly to prevent the fungus from spreading. For the treatment, the fungicide application, we apply to the tree as the preventive measure or in early stage of the infection. The stabilization, which is we do the in case the way the dry basal rot has weakened at the tree structure, stabilize measure such as cabling or bracing or pruning may be necessary to reduce the risk of the tree failure. And the effect this disease to the economic or the yield is not typically associated with the oil palm plantation. Instead, it more commonly concerned in the relation to the tree particle hardwoods trees in the forest or the urban environment. Basal rot primarily affect the structure integrity of the tree and the timber of industry rather than agriculture crops like oil palm. Therefore, it unlikely to have a direct impact on the yield or economic losses of the oil palm plantation.
Hello, my name is Tikas Nakayanamuddin, and next I will present the next disease, which is called bunch rot disease. Bunch rot disease, also called fruit rot or stem end rot, is a fungal infection impacting oil palm Alisguenesis plantation. It specifically affects the fruit bunches, causing diverse symptoms and economic losses in the industry. For this disease, the causal agent is Marasmius palmivorus. The bunch rot exhibits a potential for spreading from infected palms to the healthy ones, particularly in plantations with inadequate disease management practices. The prevalence of warm and humid conditions favors the development of bunch rots, making it a notable concern in tropical region where oil palm is cultivated. Next, we will look into the sign of this disease. The indicator involve lesion on fruit branches, characterized by dark brown to black mark on the surface. Additionally, there is a foul odor emanating from infected branches. Finally, the ripe fruits within affected branches undergo blackening. Simultaneously, for the symptom, there is premature fruit drop as a symptom affecting affected bunches. This is followed by internal decay, jeopardizing the fruit's pulp. Moreover, there is an adverse effect on oil quality, resulting in elevated acidity and impurities. Management approaches encompass adopting sound agriculture practices, maintaining proper sanitation, removing infected palms, and cultivating resistant palm varieties. While fungicide may be utilized in certain instances, their efficiency may be constrained. Consequently, bunch rot disease has the potential to markedly diminish oil palm fruit yield and quality, resulting in economic setback and for both oil palm grower and the oil palm industry. Following next, the next disease is lethal yellowing disease. The lethal yellowing disease is a serious disease that affects various species of palms, including oil palms. It is caused by a phytoplasma, which is a type of microscopic organism that is similar to bacteria. Usually, it is transmitted by insect vector, particularly plant hoppers. The key indication is frond yellowing, primarily starting at the bottom and advancing upward in advanced stages. Affected fronds may prematurely drop, leading to a decrease in canopy density. Following that, the signs include premature fruit drop, where fruits fall before reaching maturity, resulting in a significant decrease in the number of mature fruits on infected palms. Subsequently, there is stunted growth, characterized by infected palms displaying reduced growth compared to their healthy counterparts, featuring shorter and smaller plants. Moreover, efficient management involves soil improvement achieved through proper fertilization and organic matter handling, enhancing the overall well-being of oil palm tree. Palms with robust health exhibit greater resistance to diseases. Additionally, fungicide treatment may be incorporated in disease management plans, though their effectiveness in controlling lethal yellowing can be varied. Their use should be judiciously determined based on specific circumstances and expert advice. Hence, the economic consequences involve premature fruit drop, a conspicuous effect of lethal yellowing disease. Infected palms may witness a decrease in fruit production, resulting in significant yield losses. Additionally, there is diminished oil production, as this disease adversely affects both the quality and quantity of oil extracted from affected palms. Next is spear rot with the causal agent of Fusarium oxyporum species. This can be transmitted through contaminated pruning tools, soil, and infected planting material. It can enter the palm through wounds or injuries to the spear leaf during cultural practices. Subsequent indication of this disease encompass wilting and discoloration, with the initial symptoms manifesting as drooping and turgor loss in the spear leaf. As the disease advances, the spear leaf may collapse, indicating a substantial sign of spear rot. Next, symptoms involve wilting and discoloration, typically initiating at the base of the spear leaf, advancing upwards, leading to the leaf collapse. The affected spear leaf may display a brown to dark brown color, accompanied by a foul odor. Efficient disease management involves swiftly removing and eliminating infected spear leaves to control disease spread. Cultural practices, including maintaining proper sanitation and hygiene during field operation, are essential for minimizing infection risks. Additionally, the development of disease-resistant oil palm varieties enhances resilience against spear rots. Hence, spear rot has the potential to cause the death of the spear leaf, disrupting the normal growth and development of the oil palm. Given the spear leaf's crucial role in the healthy development of field leaf, the disease can significantly affect the overall productivity of the palm. This is all of my presentation. I will pass to the next presenter.